Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all doing well. Dear students, this lecture is for grade 7, boys and girls both wings. Subject science. We will do the chapter number 8, which is about transmission of heat. This is my 22nd lecture, and I am your lecturer, Mrs. Saira Jamal. Activity 8.3. Water is a bad conductor of heat. Water and most other liquids except mercury are bad conductors. To show this, wrap an ice cube in wire gauze. This is wire gauze. Take an ice cube and wrap in it in this wire gauze. You can see in this image, this is an ice cube wrapped in wire gauze, and drop it in a test tube. This is the test tube, almost filled with water. This ice cube, which we wrap in wire gauze, as it is heavy, it will settle down at the bottom of the test tube. Hold the test tube and heat it near the neck with a Bunsen flame or spirit lamp. This is called Bunsen burner, and the flame definitely is called Bunsen flame. And this is called test tube holder, with the help of which you can hold the test tube and you can warm it by using this flame, and you will not burn your hand by using this test tube holder. What will happen when you will heat the neck of this is the neck of the test tube, and we are heating the neck of the test tube. Soon the water in the upper part of the test tube will start to boil, but the ice at the bottom melts very slowly. It shows that water is a bad conductor of heat. This part of the water will start boiling and the ice will melt very slowly. This very slowly melting of ice confirms that the heat which is conducted by the water to the lower part is very slow. That's why the melting of ice is very slow, which confirm that water is a bad conductor of heat. Applications of conduction of heat. Conduction plays an important role in our lives. Cooking utensils, electric kettles, iron, soldering irons. This is the you can say an object or an appliance used for the soldering of iron or joining of iron parts, etc. are made of metals to conduct heat quickly. Their handles are made of plastic or wood. You know that plastic and wood are bad conductors, so like the handles are wrapped with the plastic. You can see even here the handles are these are the plastic or the rubber to which these metals are wrapped, because metals are good conductor of heat, and then the metal is wrapped with plastic or rubber. So even with wood, which are bad conductors of heat and electricity. The birds have feathers which keep their bodies warm, because feathers are bad conductor of heat, so their body temperature remain same. Woolen clothes and blankets slow down the transfer of heat. It happens so because the wool traps the warm air in it and does not allow the cool air to move inside the blanket, because the blanket and the warm clothes are insulators that trap the warm air inside the blanket and will not allow it to move outside. So the air is a bad conductor of heat. Ice is covered with jute rugs. This is the jute. These are the jute, you can say, ropes from which these jute rugs are formed. So jute rugs are used to cover the ice. And what happened by using these jute rugs, because as these jute rugs are insulator, they are bad conductor of heat. So the ice will melt very slowly, or you can say these jute rugs reduce the melting speed of rice. Jute is a bad conductor of heat, so you can keep the ice without melting form or without the molten form for a long time. An insulating material, for example, styrofoam, is filled between the double walls of a refrigerator, and it reduces the transfer of heat across the walls of the refrigerator. Double window panes are used. You can see these are the double window panes. One, two. Double window panes are used in building to slow down the transfer of heat. Air between these two layers of glass acts as an insulator. So the rooms get the temperature of the room become constant or remain same for a long time. Thermal bottles use air or a vacuum to slow the transfer of heat by conduction. You can see over here we have a stopper of the thermos. Then a vacuum is there between the two double glass shell. These are double glass shell. One is inside, one is outside. In between the double glass shell is vacuum. We can say vacuum is present over there. There is silver coating, and then outside is a plastic coating or any metallic coating. So thermal bottle use air or a vacuum to slow the transfer of heat by conduction. Tidbits: the plastic water cooler and hot pots have double walls, and the styrofoam and air between the wall reduce transfer of heat by conduction. So again, styrofoam is placed between the walls of the hot pot and the water cooler, and that's a bad conductor of heat, so the water in cooler will remain cold for a long time and the food in hot pot will remain warm for a long time. Marble, you can see here the stairs which are made of marble. Marble has been used in buildings and monuments since ancient times. Marble not only make the building beautiful but also make it insulator. Such buildings remain cool during hot days, and if you turn on the heater in warm days, so the house remain warm for a long time because they are insulated. The next type of transferring of heat or conduction or transmission of heat is convection, which is the second case which I explained in my previous lecture, that the transferring of heat can also takes place by convection. Unlike particles of solids, particles in liquid and gases move from one place to another too. In the second option was which I explained, that the teacher will tell the students to make a line and come to the teacher table and then collect the or take the dates from the teacher. So that type of transmission of heat is called convection. So unlike particle of solids, particle in liquid and gases move from one place to another. Unlike means that the solid particles are not moving, they does not change their position. But the particle in liquid and gases, they can move, they can change their position, or they can move from one place to another. Same like the students left their seats and they went towards the teacher, so they move. So gases and liquid molecules, as they are moving, so this type of transmission of heat is called convection. Take a beaker and put small pieces of paper in it. Fill half of the beaker with water. Heat the beaker by a spirit lamp. We shall see that pieces of paper rises to the top of water, move sidewise and sink to the bottom. You can see that the water, the papers inside the this beaker, they are moving, they're going up, down, sideways. So movement is shown by the papers. Heat the water in the beaker. Also heat the beaker by aspirate lamp. We shall see that pieces of paper rise to the top of water, move sidewise. When you will heat the beaker, what will happen? The water molecule will get energy and then they will go up. First, the warm molecules are lighter in weight, so they will move up. Then the colder molecules will come from up toward down. By this way, you can see that the convection current, this is called convection current, movement of warm molecules to move up and the colder molecules to move down is called convection current. So you can see the convection current produced in this beaker. The water in the beaker also get warmed. Molecules of water absorb heat energy from the bottom of the beaker and rises to the top. Other surrounding molecules of water come to the bottom to absorb heat energy. The transfer of heat in which molecules of a medium actually move to the source of heat energy. The molecules are moving from top toward the source of heat. Suppose if it is a Bunsen burner or spirit lamp, so the molecules are moving from top toward the source of heat. They will take heat or absorb energy and then will move up. So the transfer of heat in which molecules of a medium actually move to the source of heat energy to absorb heat and after absorbing heat move away from it is called convection. This process is called convection. Convection occurs in liquids and gases only because their molecules can move freely. The molecules of a solid are held closely, tightly packed together so they cannot move freely. Therefore, convection is not possible in solid. Convection takes place in gases and liquid because the molecules are far apart from each other and they can move easily. But the solid cannot move because the particles are tightly packed with each other. The upward and down movement of molecules of water or air is called a convection current. The process is called convection and the movement of air up and down is called convection current. Activity 8.4 Convection in liquid. You will need a beaker. This is a beaker. Inside beaker is water. This stand is called tripod stand, and this burner is called Bunsen burner, or we can even use spirit lamp. And we also need a purple color compound which is called potassium permanganate, and it is also called pinky. Procedure is fill the beaker two-thirds with water, not completely filled, but two-thirds of water. Place the beaker on a tripod stand. It has you can say three legs are of this tripod stand. That is called a tripod because it has three pods or three legs. Place the beaker on a tripod stand. Place a crystal of potassium permanganate or pinky in the beaker. That potassium permanganate will go down in the beaker and then heat up this beaker. After heating, you will see that the crystal will go up. The crystal will go up, and then it will spread. It will go up, and the water molecule will come down, up and down. This up and down, or this convection current will spread this potassium permanganate crystal in the whole water, and will dissolve in water. When water is heated, the water near the flame gets hot. Hot water rises up. The cold water from the sides moves down towards the source of heat. This water also gets hot and rises, and water from the sides moves down. This process continues till the whole water gets heated, and this mode of heat transfer is known as convection. Activity 8.5 Convection in gases. You will need a box. This is a box with two holes at the top. These are the two holes at the top, and you need cloth or paper, matchbox, candle, and plastic sheet. Procedure is light a candle and place it under one of the hole in the convection box. These are the two holes. We will keep the candle under this first hole. Bring a burning piece of paper cloth near the hole other than the candle, and we will bring a burning paper or burning cloth or something near this other opening of the box. Observe the path of the smoke in the convection box, because if you will burn the paper or cloth, so the smoke will move inside this hole, and after moving this hole, where it will go, what is the path of this smoke in this box. As the air warm weighs less than the surrounding air, it rises out of the hole above. The cooler surrounding air enters the box through the other hole to make the place of the air which weigh less. This movement of air in and out of the hole due to the difference in weight set up a convection current. You can see that when the smoke inside move inside the box, so the what will happen, the warm air which is less or lighter in weight, that warm air which is from this candle, because the air inside the box will warm because of this candle flame, that warm air will move up because it is lighter in weight. So to occupy the space of that box, because the box will then get empty, the air from the box will move outside. So the air from this hole will come inside the box, which is a cold air, because as compared to this air which is warmed by the candle, the air which is coming from outside is a cold air. So this confirms that the movement of the air currents, warmer air will move outside and the colder will move inside the box. Winds and ocean currents. We know that convection is the transfer of heat by the actual movement of the particle in material. So winds and ocean currents are examples of effect of convection. The heat of the sun heat up the surface of the earth. You can see the heat of the sun heat up the surface of the earth, which will make hot land up quickly. Then what happened, as the air which is present on the land or on this area, it get warm. The heat of the sun heat of the surface of the earth, and air near it also gets hot. The air expand and gets lighter. Definitely the warm air is lighter in weight and it will expand and move up. You can see in this image, air warms become less denser or lighter will rises. It will go up. So it rises up, and the cool air from the surrounding, or the cool air which is present in the neighbor, that cool air will move down to occupy this space. This cool air become more dense, heavier, it will simply go down, and if it will go down, then the air from the seaside will move towards the land. So that's why the areas which are closer to the sea or the river, their temperature get moderate due to this cool air which are coming from the sea or from the river side. So as I told you that due to the sunlight, the heat of the sun, it heat up the surface of the earth, and then the air near to it also gets hot. The air expand and get lighter, so it rises up, and cool air from the neighboring region moves in to fill its space. The rising warm air reaches upper cold layer of the air and cools down. Cool, heavy air sinks to the earth in cold region to blow again to take place of the rising air. Thus, convection current are set up, and the wind system goes on, which maintain the temperature of the uh, mm, coastal side. Convection causes wind. Ocean current are also set up due to the convection of heat. Water of the hot region of an ocean gets hot. It expands and gets lighter, but water in the colder region remains cold and heavy. Hot water moves along the surface of the ocean toward the colder region. The cold water flows below the surface of the ocean towards the hot region. In this way, the ocean currents are set up. Even in the ocean, what happened inside the ocean, the upper surface, as it is warm by the heat of the sun, so that will move up, and then the water from the downside, which is cold, will come to occupy that the space of that warm water. So ocean current will set up. Another application is gliding flight of birds. Gliding flight means when the birds are not moving its their wings, and they are just flying with the air currents. So it is called gliding flight. Convection and gliding flight of birds. Convection current also take place in atmosphere. The heat from the sun warms the air near the ground. The warm air expand and become lighter in weight. As warm air rises, colder air rises to fill the spaces. This process continues. So birds like eagles, hawks, vulture, and gulls take advantage of this phenomena, and they enjoy gliding. During gliding flight, as they are not moving their wings, so what happened during gliding flight, a bird does not move its wings but glides on air currents. A large amount of energy or a lot of energy of bird is saved during this gliding flight. Then everyday application of convection current, some more application of convection current. We can observe the use of convection currents in our surrounding, like household ventilation can make our house cool. The air which we breathe out is warmer and lighter. It moves up in the room to go out of the ventilators near the top side of the wall. Fresh and cool air enter the room through windows and doors. You can see this is a house, and the cool air, it is entering in the house through the windows or through the ventilators, and the warm air is moving out of the house. So by this way, the temperature of the home can be maintained. The warm air is moving out. These red arrows mean warm air is moving out, and the cool air is moving inside the house through ventilators or through windows. In a domestic water heater, water is heated in the boiler by gas burner or heating coil. Heating coil means like you can also use electricity for this purpose, for warming the water. So when we turn on the electric switch or the fire, the water at the downside become warm first. That warm water will rises and flows into the upper part of the water heater, and the cold water then comes down to occupy the place of uh, the warm water. So this water rises and flows into the upper part of the water heater to take place of hot water. Cold water from storage tank or from the site falls to the lower part of the water heater to be hot. We take the hot water from the tap attached to the water heater. Convection current help in the continuous supply of hot water. Then an air conditioner also uses convection current to cool a room. Air conditioners are installed near to the ceiling. The rotary fan of an air conditioner releases cool dry air. The cool dry air is heavier in weight, so it sinks, and the warm air of the room rises because it becomes lighter in weight. The air conditioner draws this warm air to make it cool again and again. Desired temperature is gained. You can see that the air conditioner is fixed in wall, and the warm air is taken in by the air conditioner and cooled it, because a condenser in air conditioner will condense the air and will make the air cool. An air conditioner gives out cold air which falls inside the room, and this pushes the warm air up. The cold air will push the warm air up, and then it will move out from the room, and by keeping the temperature of the room colder. So this was all about the convection, some activities to understand the convection and application of convection. After conduction, this is the second form of the transmission of uh, heat, which is called convection. And this is related with the second option, which we discussed in our previous lecture, where the students are in line and they move toward the teacher desk and then collect the dates from the teacher. Same, you can see that uh, the molecules are moving toward the source. The teacher is source, and in these cases, the source is the burner. So the molecules will move towards the source, and then they will get energy from them, and then they will go up, and the other molecule will go down. So this air current production and movement of molecules actually represent the type of heat transmission, which is in this case is convection current. So dear student, hope you understand this lecture. Inshallah, in our next lecture we will do the third type of transmission of heat, which is called radiation. So till then, take care. Allah Hafiz.